and then you can watch it if you don't understand it. So number 1 is find the value of 8 to the third power. So how would you do that?
You have to go 8 times 8 times 8.
Yep, that's right. Okay, and then for number 2, because you're doing decimals, you can have a decimal on this side right here. You don't have to do anything about it. But if you have a decimal on this side, you have to clear it out. So we have a decimal right here. And to clear it out, you move the number of spaces for it to get behind the number. So you're going to move it 1, 2, and then whatever you do on this side, you do on this side. So you're going to move it 1, 2, and it goes to here. Now, this looks kind of crazy, so I always just rewrite it because that's too hard for me to work with all this other stuff right like this. So the problem becomes 5 on this side and then 8,565 on this side. Does that make sense to you?
Yeah.
And then you just do the math. Okay. For number 3, Kent burns 1,380 calories in 6 hours of downhill skiing. At that rate, how many does he burn in 1 hour? So how would you figure out what the answer is? Would you add, subtract, multiply, or divide?
For this one, you have to divide.
Yep. So the problem becomes 6
divided by
1,380 divided by 6. Yep. And then do you know how to multi-digit divide, right?
Yeah.
Okay. And then you would label the answer, whatever it is, calories.
Yes.
Okay. A triangular prism has 2 congruent triangular faces and 3 congruent rectangular faces. Draw the triangular prism and find the surface area. Okay, did you do surface area last year?
Yes.
Okay,
we did some of it.
Yeah, we're going to skip it for now because it's pretty hard and we can handle surface area all at one time. I'll teach it to you all together. So just skip number 4 for now and then we'll come back to it. So I'll write a note to teach surface area. All right, next one is graph these integers on a number line. So we would just make a number line and then you would label that answers. So the lowest one is 15 and the highest one is 20 and they're negative numbers. So they're actually the opposite direction because it's negative. Does that make sense to you?
Yeah.
And then you would just write a point at each of those integers. So negative 20, negative 18, and you would just make a point. That's all they're asking for that one. Does that make sense to you?
Yeah.
Okay. In August, the ice cream parlor serves 28 banana splits in 4 hours. So I'm just going to write that down. About how many will they sell in 7.5 hours? So how would you go about figuring that out?
Do you have to do 4 divided by 28?
Yeah. So that would be what?
7?
7. And then what would be your second step?
Wait, what?
What's your second step?
And then after that, you have to go 7.5 times 7?
Yep. So it would be 35, and then 7 times 7 is 49, plus 3 is 50, 51, 52. And then do you remember what to do with the decimal?
Yeah, you just drop it down?
If you're adding or subtracting, yes. But if you're multiplying, you find out how many spaces it goes in from the end of the number. So how many does this go in?
Wait, how much times does 7 go into 3?
No, how many spaces does this go in?
1.
Yeah. So you make an imaginary decimal here, and you make it go in one time right here.
Okay.
So I'll go over this concept with you. So the answer is 52.5 banana splits. And then I'll go over, do you want me to go over decimals?
Yeah, sure.
Okay. So you write the problem out, you line it up like you normally would as if the decimal isn't there, and you solve it as if the decimal isn't there. So 25 and then 56, 58. Okay, so you get your answer, and then you're basically going to go in however many spaces from the end of the number to the decimal. So this is 2 spaces. So you make a decimal at the end of your number and you go in 2. So it becomes 58.56. So for addition and subtraction, we line it up. For multiplication, we do not. So suppose we had, instead of the decimal right here,
Yeah.
suppose we had just that same number, but then we also had a decimal here. We would also count that. So this would be 2 spaces and this would be 1. So our answer would be, you put your imaginary decimal at the end and you'd go 1, 2, 3. So it would be 5.856. Does that make sense, or do you want me to do another one?
That makes sense.
Okay, so I want you to write this down. So step 1 is to do the multiplication like normal. And we're going to call this multiplying decimals. So these are going to be your notes. Keep them all in one spot. So step 1, do the multiplication like normal. And then step 2, count how many jumps the decimal is from end of number. So for this one, it was 2 jumps. For this one, it was 3 because we have this one and this one. Then step 3 is to put a decimal at the end of the answer. And then jump the decimal the number of spots or spaces. Make sense? Did you get all that down yet, honey? I think you're on mute.
Oh, yeah.
Okay. All right, next problem is Mandy wants to paint the top part of her kite pink and the bottom orange. What is the area of each part? So how would you figure that out?
You would have to do 10 times 12.
Okay, let's save that, so we'll come back to that. We'll do all the geometry stuff after. Okay. Study the data set. What is the difference between the lowest value and the highest value? Of number 8. Okay, so we go to number 8. The lowest is what number?
11.
And the highest is what number?
59.
Yeah. So this is the lowest, and this is the highest. Now,
So right, lowest and highest.
well, so the question is, the number represents the blank of the data set. What do you think the answer is? Do you remember what, honey?
I didn't say anything. Okay.
So, do you remember learning about mean, mode, range, median?
No, I don't think I ever learned that.
You had to, or they wouldn't have it in here. Okay, so it is the range. I will go over that with you as well. And then number 9 is compare 10.5 and 3.2 on the number line. Which number is smaller?
Oh.
Which number is smaller?
Which number is the smallest? 3?
Yeah. Yep.
Okay, so do I just circle 3?
Yeah.
Okay.
Okay, number 10. Identify the variables in the expression 2D, 4F, and then plus 7. What is a variable?
Is it the letters?
Okay, so for number 10, on your notes, so I want you to keep a note. These are the concepts that you don't understand. So the first one was multiplying decimals. We cleared that up, right? Then on that same notebook or the same page or whatever, you're going to write 4x minus 7 equals 5. And then you're going to label this coefficient. You're going to label this variable. You're going to label this constant. And you're going to label this constant. And then let me know when you're done with that, and I will tell you what all of that means.
I'm done with it.
Okay, so what this means is the coefficient is the number attached to the variable. So like 3x, 4y, this is the coefficient. Okay. Then the next thing is the variable. That is the letter. So in this case, it is x. And then the constant means it is a number that doesn't change. So do you see how this is going to change? This 4 is attached to the variable.
Yeah.
Okay, so the constants are the numbers that don't, in this part, I mean, they eventually change, but here they don't change in the problem.
Okay.
Okay, so that is what the variable means. So number 10, the variables in this problem are what?
The variables are x.
Number 10 though.
Oh, number 10. Oh, it's F and D.
Yep,
So do I just write F and D?
yep.
Okay.
Okay, the next one is the bakery has 64 donuts left. There are 20 powdered sugar donuts, 20 chocolate frosted donuts, and 24 cream filled. Write the ratio of powdered donuts to sugar donuts. So to frosted. And then the second part is write cream filled to total number of donuts left. So how would you do this?
Okay. Let's get water. I'm writing. Do I have to write this down?
Yeah.
Okay. Okay, so you'll have to add them.
So do you remember learning about ratios?
No.
Okay, so a ratio can be shown as a fraction, as this, when you say blank to blank, or as a number colon another number. And what they're asking for is, suppose that in a classroom,
Yeah.
you have, how many students do you have in your classroom?
32.
And how many do you think are boys?
20.
So 20 boys and 12 girls, right?
Yeah.
Okay. They're going to ask you to write a ratio. So a ratio says that you do, this is always the first thing named. So if I ask you to write a ratio boys to girls, you're going to put the number of boys here. Then you're going to either do a colon, the letter, the word 2, or you're going to do it as a fraction, but we're just going to do it one at a time. So for this time, we're doing 20 and then a colon, and then how many would I put for girls?
12?
Yep. So if girls were named first, then you would put 12 here and you would put 20 here. But it's asking, we have to keep it in the same order. So whatever's here is going to go first and whatever's here is going to go second. Does that make sense?
Yeah.
Okay. Now we're going to do the same exact problem, but we're going to do it blank to blank. So what would go here and what would go here?
First would go 20, and then second would go 12.
Yep. And then the third way is a fraction. So the first thing named would go here, and the second thing named would go here. So what would go on the numerator?
20 would go first.
Yep. And then what would go on the denominator?
12.
Yep. So they're asking about powdered sugar
Powdered sugar donuts, chocolate frosted donuts, and cream filled.
Yep. So it's going to be write the ratio of powdered sugar donuts to chocolate frosted. So what would go first?
First would go powdered sugar.
Mm-hmm. And we would write it like this.
Well, there's 20 powdered sugar, and there's also 20 chocolate frosted donuts, so they're the same.
Yep. So the powdered sugar would be 20, and then the chocolate, so it'd be 20 to 20, 20 to 20, and then 20 over 20. So you can write it all three ways.
Okay, since chocolate and powdered sugar are the same, can you reverse it and put chocolate first and powdered second?
They're not the same. So powdered sugar donuts is the first thing that they named. And then the second thing they named is chocolate frosted, which it's still 2020, but you always do the first one first.
Okay.
So on your notes, you're going to say there are three ways to write a ratio. And then you're going to list 1, 2, 3. And then this is the most important thing, that the first thing named goes first and the second thing named goes second.
Okay.
Now we're going to do the second part, cream filled to total number of donuts left.
So now I have to list all three of them?
So just cream filled. So for number 11, it's going to look like this. Powdered sugar to chocolate, 20 to 20, 20 to 20, and 20 over 20.
Okay.
And then the second part is going to be cream to donuts left. And so how many are the cream?
There is 24.
And then how many are left?
None.
So read the equation again.
The bakery has 24 donuts left. There are 20 powdered sugar donuts, 20 chocolate baked donuts, and 24 cream donuts. Write the ratio of powdered sugar donuts, chocolate frosted, and write the ratio of cream filled to the total number of donuts left.
Yeah. Read the first sentence again.
The bakery has 24 donuts left.
It doesn't say 24.
The bakery has 64 donuts left.
Yeah. So how many donuts are left?
64.
Uh-huh. So what would be the second part of this ratio?
There are 64 donuts left.
Yeah. So it'd be 24 as the first part, and then the second part is
64 donuts left.
Yep. So we write it three ways. We write it like this, we write it like this, and we write it like this.
Okay, what is?
All right. Make sense?
Yeah.
Okay. We're going to skip 12. It is volume. We'll do volume with your geometry. And then number 13, does this make sense to you or no?
Right in a turbulent expression. I've heard of it before, but I don't remember it that well.
Okay, so here it is. Greatest common factor is whatever the two numbers that we're comparing have in common, and we want the
I know what the greatest common factor is.
Yeah. Okay, so what is the greatest common factor of 12 and 14?
12?
So we're gonna actually write down the numbers. So what are the factors of 12 and what are the factors of 14?
The factors of 12 are 12, 2, 4.
So we're gonna go in order, Jalen. So we're gonna do, does 1 go into 12? Yes. Does 2 go into 12? Yes. Does 3?
Yes.
Does 4?
Yes.
Does 5?
No.
Does 6?
Yes.
7?
No.
8?
No.
9?
No.
10?
No.
11?
No.
And then 12.
Yeah.
Yes. And then we're going to do the same thing for 14. So 1 goes into it, 2, 3 does not, 4 does not, 5 does not, 6 does not, 7 does, 8 does not, 9 no, 10 no, 11 no, 12 no, 13 no, 14 yes. Now we look at our list and we see what the biggest common number is of both numbers.
Bye, Mom. Bye, Mommy.
Take your water bottle. Oh, Theo's gonna take your face bottle.
The common thing, the biggest one is 2.
Yep, so we circle it.
Okay.
And then they're saying that our expression is 12a minus 14. So
12, 8, minus 14.
the distributive property means that we put the greatest common factor on the outside of the parentheses, and then everything else is going to go on the inside. So if you had 12 and you divided it by 2, what would you get?
6.
So we're just working with this part right now. And we have a 6 because the times 2 is already here. And then we can't take the a out, so we put the a here and we put the subtraction out. And then we already have 2 here. And we're going to be multiplying this, so that means what is 14 divided by 2?
14 divided by 2 is 7.
So do you remember the distributive property means that you distribute this and this inside the parentheses?
No.
You don't remember that? Okay, so the distributive property means that anytime a number is touching parentheses like this, you take this number and you multiply whatever you have inside of the parentheses. That doesn't make sense to you?
No.
Okay. All right, I will go over that. Okay, number 14. Think about the inequality t is more than or equal to -2. Do you remember what that means?
No.
Okay.
I didn't learn any of this. In 6th grade, we just reviewed it and we just learned a little bit of algebra.
Okay. So what they're saying is that these numbers listed right here, the 6, the 2, the 0, the -2, and the 6, you're going to write on your notes, these are all t. So basically what you're going to do is you're going to take this number and you're going to plug it into this equation. And you're going to say, is that true? Is 6 more than or equal to negative 2? Yes or no?
Yes.
Yes. So 6 is correct. Now you're going to do the same thing with the next one. You're going to take this 2 and you're going to put it where the t is. Is that true or is it not true? 2 is greater than or equal to negative 2.
It's not true?
It is true because 2 is greater than negative 2.
Oh, I thought that was just a normal two. Okay.
So 2 is a solution. Is that right?
Yeah.
Okay, now we're going to do 0. So we're going to plug 0 in and we're going to say, is 0 more than or equal to negative 2?
Less than?
No, 0 is more than negative 2.
Okay.
Would you rather have $0 in the bank or negative $2 in the bank?
0?
Yeah, you don't want to owe the bank money. You'd rather have like $1,000, right? But if you had to make a choice, would you rather have $0 or negative $2? Would you like to owe the bank money or would you like to just have a 0 balance?
0, just to,
And why would you want to have a 0 balance instead of a negative 2 balance?
because negative 2 is worse.
Yep. So 0 is bigger than negative 2, right? So is this statement true? 0 is more than or equal to negative 2.
Yes.
True, right? Awesome. Okay, now we're going to go to the next number. Is negative 2 greater than or equal to negative 2?
It's equal.
So is this true?
How is that? How is negative 2 bigger than negative 2? Isn't it equal?
But this means or equal to. Do you remember learning about this? Greater than, less than, greater than and equal to, or less than and equal to. So this line down here says that it could be either greater than or equal to. This
Okay.
line down here says it could be less than or it could be equal to. So,
Yeah, I remember learning that.
okay, well, I'm teaching it to you now, Missy. So is this true?
Yes.
Okay. And then we're going to do our last number. So negative 6 is greater than or equal to negative 2. Is that true?
No.
That is the only one that is not true. So for number 14, you're going to write 6, comma, 2, comma, 0, comma, negative 2. Those are all the values.
Okay.
Does it make a little bit of sense?
Yeah.
Okay. All right, let's go on to number 28.
28. Where's that at?
Page 28.
Oh, lesson or page?
Page.
Okay. We didn't do 14.
This is
Oh, wait.
14.
Oh, I put 13 and 14.
No, so number 13 is this. 2, 6a minus 7.
Okay. Okay. I'll just do 14 next page.
Did you finish number 13?
Yeah.
Okay. All right. Number 1. 9 plus 32 minus 7.
We have to do 9 plus 32 minus 7.
Yeah.
32 plus 9. 9. Okay, it's 14, I think.
And how did you figure that out?
Cause I did 32 plus 9 and then minus 7.
Okay, so 32 plus 9 is what?
I got 41.
And then 41 minus 7 is what?
14.
Does that seem right to you?
No.
Okay.
Look, you have to cross out the 1 and make it an 11, and then cross out the 4 and make it a 3. So then that would make it. I don't know how I do this.
34, right?
Yeah.
Jalen, can you go into your room or something?
Sure.
Okay, I'm going to go on to number 2. So 7x squared plus 4x plus 9. There are 3 terms. 7x squared, 4x, and 9. Identify the terms in this expression. So we have 4 terms here. We have 7p to the 3rd power, 2t to the 2nd power, 8t, and then 4. So you're going to write for number 2, 7p cubed, or to the 3rd power, 2t squared, or to the 2nd power, 8t, and then 4. Those are our 4 terms for number 2. Number 3, we have 17a plus 32b plus 15 plus 2a plus 3. So they're asking you to write an equivalent expression. So what that means is that you're going to combine like terms. So what are the like terms here? We have 2a terms, we have 17a, and we have 2a. And those match. They're the same exact variable. So 17 plus 2 is 19a. And then we have 32b, and nothing else here is a b. So we just rewrite the 32b. We don't have to combine it with anything. So we're done with that one. And then the ones left are 15 and 3. Now these are the same type of expressions because they're both just regular numbers without any letters. So we combine these. 15 plus 3 is 18. And that's all that you have to do for that one. Okay, they're asking you for number 4, which expression is equivalent to 20k. So we're going to go over here. I'm just going to write 20k. 15k plus 5, is that equivalent to 20k? No, because we cannot combine a K with a number. If this was 5K, then yes. But because this has a K attached to it, and this is just a plain old number, we cannot combine those. So this one is not true. For this one, we're going to do the thing that I talked to you about, the distribute. So this parentheses and this number are touching each other, right? There's a parentheses and there's a number right before the parentheses. That means we multiply anything outside of the parentheses to everything inside the parentheses. So 2 times 5 is 10, and then 2 times k is 2k plus 10k. So we're going to combine like terms. We have these two that are the same. 10k and 2k equals 12k, and then we have this 10 over here. So 10 plus 2k. That is not equal to 20k. All right, we have, so this is not an answer. And then we have a number touching a parentheses, and that means we multiply to anything inside the parentheses. 2 times 5 is 10, and then we have a k plus 10k. Now, because this has a number and a letter k, and this has a number and a letter k, we can combine these. The numbers can be different. This could be a 10 and this could be a 7 or a 4 or a 20, but the k's have to be the same. They can't look like k squared or k cubed or anything like that. So because this is just a plain old k, and this is a plain old k, and this is a plain old k, we can add these numbers together. 10 plus 10 is 20k. So the only one that is true for these three problems is C. Are you still with me, Jalen?
Hello?
Hi. Okay. Are you still with me?
Yeah, I just got here. There's a lot of people. I'm not even at my house. There's a lot of people here.
Oh. Okay,
There's
so
no-
I just did a video for number 2, 3, and 4 if you didn't see it. So you can look back on the video.
Okay.
Okay, number 5. Which value for t makes the equation 11 plus 7t true? Do you understand what that means?
Is it saying if the t wasn't, it means like the t means something, and if it wasn't there, then it wouldn't be true?
No, it means if the t stands for something, what would it stand for to make this true? So t can equal anything. It can equal 1, it can equal 2, it can equal 3. So we have to plug in numbers to see if t equals 1.
It would be 13.
No, because this is multiplying, honey.
Oh.
So we're saying 11 plus 7 multiplied by something equals 32. So we know it's not 1, right? So let's try some of these out. Could it be 1?
No.
No, because 11 plus 7 is not 32. So we know that's not true. Could it be 2? So let's try it. 11 plus 7 times 2 equals 32. What is 7 times 2?
7 times 2 is 14.
Okay, so I'm just going to erase this. Is 11 plus 14 32?
11 plus 14 is not 32.
Nope. So that is not true. What about 7 times 3? What is 7 times 3?
7 times 3 is 21?
Yep. Is 21 plus 11 32?
No.
Are you sure?
Oh, yeah, it is. Actually.
Okay, so that is the answer. 3 is the answer.
Okay.
And so you're going to write what I have here. 11 plus 7 times 3 equals 32, and then you're going to write 21 like that.
Okay.
All right, now we can do one more.
Okay.
Avery spent 3 hours making 6 centerpieces for the banquet. Write and solve a multiplication equation to find out how long it took Avery to make 1 centerpiece. So it took 3 hours to make 6. So what would you write there?
You would write 3 divided by 6?
Yeah. And that would give you 2. So you would do 3 times 2 equals 6. And that means that it took her 1 hour to make 2 centerpieces.
Okay. So is that the answer that I should write down?
So you're going to write
Oh.
So that is the answer.
Okay.
All right, my darling, I am going to send this to you. I don't know if I have your school account. I don't think I do. Let me see.
You could just send it to my mom.
Let me see. I think I have yours. All right, darling, I will send it to you.
Okay, bye.
Bye.